Hello guys, welcome to Rock Mystery YouTube channel. In the last class, I solved these so many problems on mass percentage, volume percentage and mole fraction. In today's class, I will solve still more problems on mole fraction, molarity and modality. Okay, let's start the class. And the first numerical is again on the mole fraction only. So what it says, first problem of today's class is calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. So first I will write the data, thereafter I will calculate the mole fraction of ethylene glycol. So let's start. Solution. What he has given first to 20% of ethylene glycol. That means 20% of ethylene glycol. That means 20 gram of ethylene glycol present in 100 gram of solution. 20 gram of ethylene glycol present in 100 gram of solution. That means mass of solute becomes mass of solute 20 gram and mass of solution is 100 gram. That means mass of solvent is solution minus solvent, which is equal to 80 gram. That means mass of solvent is 80 gram and mass of solute is 20 gram, and here solute is ethylene glycol and solvent is, as we all know, if it is aqueous, in the sense water should be present in the form of solvent. Okay, now we have to calculate the mole fraction of ethylene glycol, and as we all know, before calculating the mole fraction, first we have to calculate the number of moles. So for that reason, first I will calculate the number of moles of ethylene glycol, that is number of moles of ethylene glycol, which is equal to given mass by molar mass. Given mass is, as we all know, 20 gram and molar mass of ethylene glycol is C2H6O2, that is atomic mass of carbon is 2 into 12, sorry, atomic mass of carbon is 12, 2 into 12 plus, and atomic mass of hydrogen is 1, 6 into 1 plus atomic mass of oxygen is 16, that is 2 into 16. It becomes 24 plus 6 plus 32. 24 plus 6, 30, 31, 32. It becomes 62. That means molar mass of ethylene glycol is 62. And the number of moles of ethylene glycol, that I will write later. And one more is number of moles of water, that is number of moles of water is equal to, again given mass of water is 80 gram and molar mass of water, as we all know, 18 gram. The number of moles of ethylene glycol becomes to 0.322, and similarly the number of moles of water becomes 80 divided by 1/8, which is equal to 4.44, and the total number of moles becomes, that is total number of moles is equal to 4.766. Okay, now we can easily calculate the mole fraction of ethylene glycol, that is mole fraction can be represented by G, or we can say X antu karibodu, we can say X of ethylene glycol, that is mole fraction of ethylene glycol is equal to number of moles of ethylene glycol, that is 0.322 divided by total number of moles of solution, that is 4.766. Therefore the mole fraction of ethylene glycol is, which is equal to 0.06756. So this is the mole fraction of ethylene glycol. Mole fraction of ethylene glycol is 0.6756, and as we all know, mole fraction of water can also be calculated by subtracting the obtained value in 1, that is mole fraction of water is equal to 1 minus 0.6756. That means the answer is 0.3244. The answer is 0.3244. That is the mole fraction of water can be calculated by subtracting the obtained value in 1. That becomes 0.3244 is the mole fraction of water. So this is the calculation of mole fraction of ethylene glycol when 20% of ethylene glycol is given. So this is the first numerical of today's class. And the second numerical is calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. Given that the molar mass of benzene is 78 gram per mole and the molar mass of carbon tetrachloride is 152 gram per mole. Okay, here what is saying again, he is saying that calculate the mole fraction of benzene when 30% of benzene present in carbon tetrachloride. Again, I'll read the solution data, that is solution. First, what he has given? First, he has given 30% by mass, which means 30 gram of benzene present in 100 gram of CCl4 solution. 30 gram of benzene present in 100 gram of CCl4 solution. That means the mass of solute becomes here, mass of solute in the sense benzene, mass of benzene which is equal to 30 gram and mass of solute, mass of solution 100 gram. Now the mass of solvent is mass of solvent is equal to solution minus solute which is equal to 70 gram. Therefore, the mass of solvent is 70 gram, mass of solute is 30 gram and mass of solution is 100 gram. And as we all know, before calculating the mole fraction, first we have to calculate the number of moles of respective solute as well as solvent. First, I will calculate the number of moles of benzene. Number of moles of benzene, that is C6H6 is equal to given mass of benzene is 30 and molar mass of benzene is 78. As we all know, 78 is the molar mass of benzene and the given mass of benzene is 30. Number of moles I will calculate now only. And the number of moles of CCl4, that is carbon tetrachloride, is equal to given mass by molar mass. Molar mass of CCl4 is 152 gram per mole. So now the number of moles of benzene is 0.384. Similarly, the number of moles of CCl4 0.460 and the total number of moles is 0.384, which is equal to total number of moles. Total number of moles is equal to 0.844. So this is the total number of moles, and also I have calculated the number of moles of benzene as well as CCl4. Now calculation of mole fraction. Now I have to calculate the mole fraction of benzene. That is mole fraction of benzene which is equal to number of moles of benzene, that is 0.384 divided by total number of solution 0.844, which is equal to 0.454. Therefore, the mole fraction of benzene is equal to 0.454. Mole fraction of benzene is equal to 0.454, and we can also calculate the mole fraction of CCl4, that is X of CCl4, which is equal to 1 minus 0.454, which becomes, how much it becomes? 1 minus 0.444, which is 0.546. That is mole fraction of CCl4 is 0.546. So this is the mole fraction of benzene calculated when 30% of benzene is given Okay, this is second numerical. Now the third numerical. The third numerical is based on the molarity. Molarity. What is saying? Just see here. Calculate the molarity. That is capital M. Molarity in the sense capital M of a solution containing 5 gram of NaOH in 450 ml of solution. Okay, simple question is there. Just see here. First I will write the given data solution. What he has given? First he has given mass of solute, that is 5 gram of NaOH. Mass of solute is equal to 5 gram. And he has also given the volume of solution. Volume of solution is volume of which is equal to 450 ml. Now what he is asking, calculate the molarity. Molarity is equal to how much? First we have to calculate the molarity. For that we know the formula. Molarity is equal to given mass by molar mass, that is given mass by molar mass into volume of solution in liter. If it is not given in liter, we have to take in ml and multiply by 1000. I think here is given in the ml first, so we have to multiply by 1000. So for that reason, first I have to write the given mass and molar mass. The given mass of solute is 5 gram. I'll write here 5 gram, and molar mass, as we all know, molar mass of NaOH is 40 gram. How? Sodium is 23, atomic mass of sodium is 23, and oxygen is 16, and hydrogen is 1. That is 23 1 24, 24 on 10, 34, 34 on 6, 40, which is equal to 40 gram per mole. Okay, molar mass of NaOH is 40 gram per mole. Therefore the given molar mass is 40. I will write here. Next, volume of solution he has given, that is 450 ml, and hence it is in ml, so I have to multiply by 1000. So now here this 0 get cancel, and this 0 get cancel, and this is 5 ones are 5 nines are, then this is 2 twos are 2 fives are, and remains here 5 by 18. 5 by 18. The 5 by 18 answer is 5 by 18, which is equal to 0.277. The molarity of solution is equal to 0.277 mole per liter. Mole per liter. Why? Because it is molarity. Instead of writing mole per liter, even we can also write this is 2.77 capital M. Why? Because molarity. Instead of writing mole per liter, even we can also write 0.277 capital M anu baribodu. So this is third numerical. This is fourth numerical. Fourth numerical is also on the molarity only, but this is little tricky one is there because he has given density here. So let's see. Calculate the molarity of 20% of potassium iodide aqueous solution if the density of potassium iodide solution is 1.202 gram per ml, and given is molar mass of Ki, that is potassium iodide, is 166 gram per mole. What is asking? Calculate the molarity when if 20% of potassium iodide, they often aqueous solution, and he has given density. So first I let the data again, that is solution 20% of potassium iodide, which means 20 gram of potassium iodide present in 100 gram of solution, right? 100 gram of solution. That means mass of solute is 20 gram, and mass of solution is 100 gram. And as we all know, in molarity we have to take the volume of solution but not mass of solution. We have to take the volume of solution, not the mass of solution. For that we have to convert it. That is, as we all know, mass density is equal to mass by volume. As we all know, density is equal to mass by volume. But what we want volume. Just write here volume. V is equal to mass by density. Mass we all know that is 100 gram of solution, and density is 1.202. That is the answer. The answer is 83.19. Therefore, now what we have got now? We have got volume of solution. Therefore, volume of solution is equal to 83.19 ml. This is in ml, not in liter. Okay. Now we can easily calculate the molarity of a solution. That is m is equal to given mass divided by molar mass of solute into volume of solution in ml. I think has been again in ml only, so we have to multiply by 1000, which is equal to given mass of solute is 20 gram, and molar mass of solute, that is potassium iodide, molar mass of potassium iodide is a 166, and we have to write here multiply with 1000. Next volume of solution is 83. Volume of solution is 83.19. The answer is 1.44. Therefore, molarity of solute is 1.448 again mole per liter. Why? Because we are calculating the molarity of a solution. Therefore, the molarity of a solution is 1.448 mole per liter. This is fourth numerical. And the fifth numerical is 2.46 gram of sodium hydroxide are dissolved in water, and the solution is made to 100 ml. In volumetric flask, calculate the molarity of a solution. It's a simple one is there. So what is asking? Again he is asking that calculate the molarity of a solution when 2.46 gram of a sodium hydroxide is dissolved in 100 ml of water, and he is asking calculate the molarity. So first again I will write the data, that is solution. What he has given, mass of solute. He has given mass of solute. How much he has given? That is 2.46 gram, and he has given volume directly, that is volume of solution is 100 ml. Next we have to calculate the molarity, that is molarity capital M is equal to how much? Simple one is there, that is capital M is equal to molar given mass by molar mass into volume in ml and multiply by 1000. So which is equal to, given mass is 2.46 and the molar mass of Na, which is 40, as well know 40, and the volume he has given 100 ml and this is 1000. So these two and these two get cancel, this one 0, this one 0 get cancel. 2.46 divided by 4, the answer becomes 0.615 mole per liter. Therefore capital M is equal to 0.615 mole per liter. Why? Because we are calculating the molarity of a solution. Okay, this is fifth numerical. Now next numerical is on molality. So let's see. Calculate the molality of 2.5 gram of acetic acid in 75 gram of benzene. What is asking? He is asking that calculate the molality when 2.5 gram of acetic acid is dissolved in 75 gram of benzene. First again I will write the data, that is solution, mass of solute is equal to 2.5 gram, and mass of solvent is equal to 75 gram, and as well know we have to calculate molality, that is small m, which is equal to how much? So for molality we have to use a formula, that is given mass by molar mass, and here instead of using volume we use the mass of solvent, that is W of A, and multiply by 1000 if he has given in gram. Of course he has given in gram, so we are multiplying by 1000. Therefore small m is equal to given mass, that is 2.5 of sodium acetic acid is there na. The molar mass of acetic acid is 60. Why? Because we have formula CH3COH, we have, that is C2H4O2, 2 into 12 plus 4 plus 32, that is 24 plus 4 plus 32, 20, 30, 50, 50, 18, 58 and 60, which is equal to 60 gram per mole of acetic acid. Therefore molar mass is 60 and volume, gram mass of solvent is, that is 75, and which has given in gram, so I'm multiplying by here 1000. That is the answer becomes 0.556, that is small m is equal to 0.556. so here mole per kg it becomes mole per kg. Why? Because we are calculating the molality. There it was mole per liter na, but here it is mole per kg. Why? Because molarity is depends on mass, so we are taking here kg. Instead of writing mole per kg, we can also write 0.556 small m also we can write. Okay, so this is the molarity of a solution. Next question is again on molarity. What it says, find out the molarity of 1 liter of 93% of sulfuric acid, that is weight by volume, and its density is 1.84 gram per ml. What he is asking, calculate the molarity of an sulfuric acid when 93% of sulfuric acid, that is weight by volume, and its density is 1.84 gram per ml. Okay, he's asking simply molality. Now we have to calculate by using the given data. First I'll write the data, that is, first what he has given 93% of sulfuric acid, which means 93 gram of sulfuric acid present in 100 ml of solution. Okay, now we have got now mass of solute, which is equal to 93 gram, and mass of solution we don't know, but we know the volume of solution, that is volume of solution we know, that 100 ml, but we want mass of solvent because we have to calculate the molality. For that we want mass of solvent, we don't know mass of solvent as well as mass of solution, so for that reason we have to use this density term. Okay, we have to use that density term. What I'll do now, we know that density is equal to mass by volume. Okay, density is equal to mass by volume, but we want mass, so just do the cross multiplication, that is density into volume is equal to mass. So what is density? Density is 1.84, and what is volume? Volume is 100 ml. So the answer is 184, that is this dot and these two get cancelled, answer becomes 184 gram, which is equal to mass. So what we have got now, we have got mass of solution, that is 184 gram. Now we have got mass of solution, that is 184 gram. So now from this we have to calculate mass of solvent, that is mass of solvent is equal to mass of solution minus mass of solvent, that is 184 minus 93, the answer is 91, which is 91 gram. So this is the mass of solvent. We have got now mass of solvent. Now we can easily calculate, that is molality. That is molality, small m is equal to given mass by molar mass into mass of solvent. If it is given in gram, we have to multiply by 1000. So the formula becomes like this. Now given mass of solute is 93 gram, and molar mass of solute, as we all know, sulfuric acid molar mass is 98 gram, and the mass of solvent is 91 gram, and it is multiplied by 1000. The total answer becomes 10.42 mole per kg. Therefore molality of solvent, that is sulfuric acid, molality of sulfuric acid is 10.42 mole per kg. Okay, so this is the molality of sulfuric acid. So now last numerical of today's class is a very important numerical. Just see here. Molarity of sulfuric acid is 0.8 m and its density is 1.06 gram per ml. What will be its concentration in terms of molality? So best question. Why? Because he has given molarity and asking molality. Given molarity, asking molality. So best question is there. Just I'll write the data and we will solve now. So first, what he has given? Solution. Molarity of sulfuric acid is 0.8 m. First, what is given? Molarity of sulfuric acid has given, right? That is capital M is equal to 0.8 m. And also has given density. Density is 1.06 gram per ml has given. Okay, what he is asking? He is asking that molality. Molality he is asking, that is small m, right? So first I'll write this 0.8 m meaning. Okay, 0.8 m, which means 0.8 mole of solute present in 1000 ml of solution. Okay, 0.8 mole of solute present in 1000 ml of solution means 0.8 m, meaning is that 0.8 m of solute. What is solute here now? Solute is sulfuric acid present in 1000 ml of in solution. Now we have got moles of solute. 0.8 moles is there, but now we want mass of solute. As we all know, mass of solute can be calculated by using formula. Number of moles is equal to given mass by molar mass and as we all know, moles has given already, that is 0.8, which is equal to given mass we have to calculate, and molar mass of sulfuric acid is 98, which is equal to 0.8 into 98. 0.8 into 98, the answer is 70. X is equal to 78.4 gram. We got now what we have got now? We have got mass of solute. Now we have got mass of solute. We have got now 78.4 gram. Now what we want? We want mass of solvent. We want, but we don't know the mass of solution. We know the ml, means mass, volume of solution we know, but we have the density. We have to multiply. That is, we know that again density is equal to mass by volume, but what we want? We want mass. What he has given? He has given the volume. Just do the multiplication, density into volume, which is equal to mass. So which is equal, density is 1.06 and this is 1000. So if I cancel this decimal and this 20, which becomes 1060 gram. Okay, so now we have got mass of solution. I have got, that is 1060 gram, and we also have got the mass of solute. This is mass of solute, and also now I have got mass of solution. So now I can easily calculate the mass of solvent. mass of solvent is equal to mass of solution minus solute 78.4, which is equal to 981.6 gram. So this is mass of solvent. This is mass of solvent. Now we can easily calculate the molality of solution, that is given mass by molar mass into mass of solvent is, that is WA. If it is given in gram, we have to multiply by 1000. So which implies mass of solute is 78.4 and molar mass of solid is 98, and this is 1000. WA is mass of solvent is 981.6. So after solving this, the answer becomes 0.815 mole per kg. Therefore, the molality of solute is equal to 0.815 mole per kg. So this is the molality of an sulfuric acid. Okay, this is the today's class. So if you really like this video, please hit like button and also share this video to your friends. And if you want still more interesting video from our channel, please subscribe our channel. Thank you.